Hello friends, welcome to Shiksharthi. In this session, we shall be discussing the cosine rule. So let's start. Now the prerequisites for this session are, again as they are always, the first thing that you need to know here is the law of similarity, second, law of congruency, third, law of perpendicularity, fourth, law of parallelism. Meaning thereby, when you are doing the cosine rule, you should know the sine rule as well. Okay, now let me take a triangle here. So I am drawing a triangle here with vertices as x, y and z. And to facilitate this discussion, I am dropping a perpendicular from the vertex x on to the side, the opposite side, which is yz. And the foot of the perpendicular, I am taking it as w. Now using Pythagoras theorem, so let me write it down for you. Using Pythagoras, so using Pythagoras theorem, we'll be able to form two equations here. And which two equations are we talking about? We are talking about xw. Okay, even before I write this, so when we are talking about Pythagoras theorem, so we need to know that we can apply Pythagoras theorem in two different triangles here. So if I talk about the triangle xwy, we can say that xw whole square is equal to xy whole square minus yw whole square. Now the very first question that arises before a learner is, why are we not writing the Pythagoras theorem in its original form? Now when I say original form, what I mean to say basically is Pythagoras theorem states that the sum of this, the hypotenuse square is nothing but the sum of the squares of the perpendicular and the base. So why are we not writing it in its classical format? Because we need to find out the point of intersection between the discussions that we are going to do. And what are the discussions that we are going to do? We are talking about the triangle xwy and the triangle xwz, in which the point of intersection between both these triangles is the perpendicular, which is xw. Which is why we are not writing the Pythagoras theorem in its classical format. So once we have done this, then we can assume, let's say this is equation 1 and this is equation 2. So now talking about equation 1. So if I talk about equation 1, what are we saying? We are saying xw whole square is equal to xy whole square minus yw whole square. Okay, so we have written it again here, though if I wish as a learner, I can avoid writing this again and again, because we have already discussed this when we were talking about how to find a triangle being an acute angle triangle or an obtuse angle triangle. We have already discussed this thing earlier, so we can avoid writing it again. And as discussed earlier also, there are some prerequisites for every concept or every theorem that you're doing, which can be treated as a lemma. So in the very first place, I could have said that please treat this as a lemma, which I did not do it. But anyway, so now from here, I could have directly said from equation 1 and 2, we can directly write that xy whole square minus yw whole square is equal to xz whole square minus wz whole square. That we can directly write. In the interest of time, we can save writing this and we can directly say xw whole square, let me correct this. So this is xw whole square. So let me rewrite this. Xw whole square can be written as xy whole square minus. So once we would have written that, so you would have, now when I'm writing xw whole square, what I'm saying basically is xw whole square can be written as xy whole square minus yw whole square, which can further be written as xz whole square minus wz whole square. So using these two, we could have directly written that xy whole square is what I was writing earlier also, is nothing but xz whole square plus yw square minus wz whole square, which eventually you can write it as yw minus wz into yw plus wz. And what is the concept that you're using here? You are using the concept of a square minus b square can be written as a product of two different factors, and those two different factors are a minus b into a plus b. This is the concept that you could have used here. Once you have used this, then further you could have written xy whole square is nothing but xz whole square plus yw whole square Okay, now instead of writing it as yw whole square, let us hold our horses for the time being and let us see how can this be further shortened. So we know that yw plus wz can be written as yz, and further yw can be written as yz minus wz. I mean, this can be further broken into yz minus wz, which eventually can be written as yz minus 2wz. In short, now we can write that xy whole square is nothing but xz whole square plus yz whole square minus 2yz into wz. Okay, now using some trigonometric ratios, so what is the concept? The next concept that we are going to use here, can we say that cos z is equal to wz upon xz, that is divided by xz? Using this concept, eventually we can write down xy whole square is equal to xz whole square plus yz whole square minus 2yz, and wz from here, from the trigonometric ratio, using this concept we can write down that wz is nothing but xz cos z. Therefore, so if I wish, we can stop here and we can say this is what the cosine rule is when the given triangle is an acute angle triangle. I repeat, so this is what the cosine rule is when the given triangle, so the triangle has to be an acute angle triangle, which is AAT. And when it is an obtuse angle triangle, the only difference that you can see here would be, instead of this minus 2yz, it would be plus 2yz. And that is something that we have already discussed in our session on two different sessions on acute angle triangles and obtuse angle triangles, how to find out with the help of the sides. So taking this discussion to its final stage, from here now I can say cos z will be equal to xy whole square okay. So let me take that on the other hand side. So we'll be able to say that cos z will be nothing but xz whole square plus yz whole square minus xy whole square divided by twice of xz into yz. This is as plain as it looks. And the same thing could have been written as xz square plus yz square. Now in case if it would have been an obtuse angle triangle, you could have done it accordingly. So the best way to write down the cosine rule now, when I have to take care of both, is I could have written modulus of cos z is equal to the value that I have got here. Is that correct to say? I mean, that is for you to decide, but as far as the cosine rule goes, this is how it goes. And taking your learning to the final level is when you talk about, so we have already talked about acute angle triangles. Now when we talk about obtuse angle triangles, so which is, let's say we talk about we talk about OAT, wherein we are talking about obtuse angle triangle. So in that case, cosine rule will behave slightly differently, and that slightly different part here is cos of z. Now all the terms here that you will be getting would be positive here, so in that case you could write that this is nothing but xy, or a better approach here would be I take minus times of whatever I have written in the first, so which is just like saying this is xy whole square, so minus times of whatever we have written, so which is just like saying this is xz whole square plus yz whole square minus xy whole square. This is just for a learner to save time, otherwise we could have deduced it separately. And now if you see our earlier sessions wherein we have talked about the measures and the polarities of sin x and cos x in various quadrants, so I hope you would recollect that cos x is positive in the first quadrant and in the last quadrant. Last quadrant here refers to when cos x is the angle which is in the fourth quadrant, which has to be a reflex angle. And here we are talking about an obtuse angle triangle which would lie in the second quadrant. So whatever value that you would have got for an acute angle triangle, you just have to take the negative of that when you are talking about an obtuse angle triangle. So the more you practice this, the better you will be able to understand.